All right, welcome to lesson 1.4 of chapter 1. We're going to be talking about functions and, well, chapter 1 is functions and graphs. Specifically 1.4, we're talking about linear functions and slope. I think what you're going to find with this lesson, more like 1.1 and 1.2, is this is going to be almost purely review. So let's just get through it. And like I said, I think you'll find it review. Hopefully it's a refresher. Hopefully you don't find it too boring. I promise you we'll start getting into some more complicated things shortly. You'll probably wish we were back on just doing slopes. So, all right, here we go. Long list of objectives because each one we'll just kind of go through really quickly. So that's why we're going to get a lot in. Once we start getting into newer material, you'll see that the objectives end up being more like 2 or 3 things per lesson. Obviously, in this case, we have 7. We've got calculate a line slope. So we'll look at slope formula. We'll talk about point slope form. We're going to talk about slope-intercept form. We're going to talk about horizontal and vertical lines. We're going to talk about recognizing and using the general form of a line's equation. What you're going to find is in this text, they're calling standard form general form. So what you're used to standard form is going to be called general form, but it is the same thing. And then we're going to use model data with linear functions to make predictions. First thing is let's talk about slope. Slope by definition is the change in y over the change in x, which is why you've heard it called rise over run. The formula for it, provided 2 ordered pairs, is y2 minus y1 over x2 minus x1. So again, that is the change in y over the change in x. You can see the demonstration over here. All right, using the slope formula to find slope between 2 points. Right now you've got your x1 and y1. Down here. I guess not. There we go. So you got your x1 and your y1 and your x2 and your y2. So y5 goes in for y2, -2 goes in for y1, which makes it minus a negative, which is why it's 5 plus 2 and 7. x2 is -1, x1 is 4, so -1 minus 4 is -5. So the slope between those two lines would be -7/5. Okay, just don't leave the negative in the denominator. When we look at the different types of slope, there's 4 options. It can either be positive slope, meaning the line rises from left to right. You have negative slope, so the m value is negative, and the line goes down from left to right. It is considered 0 slope when you have a horizontal line. So the slope would be equal to 0 when the line is horizontal. When the line is vertical, there is no slope. It's considered undefined. There is no m, and that's a distinction. So horizontal line, slope is 0. Vertical line, no slope. Another form that we've talked about back in algebra is point slope form. And that's useful when instead of given 2 points, you need to find slope. All right, you already have slope. You're given a point. You substitute that information in. So the x1, y1 of the ordered pair, you substitute into the function there, into the formula there, and the slope that you're given is substituted in for m. So let's use that formula. So the slope you're given in this question is 6. So that's your m. And then you have your ordered pair, 2, -5, which is x1 and y1. So again, using the formula we just talked about in the last slide, we're substituting -5 in for y1, 6 in for m, 2 in for x1. And you end up with y plus 5 is equal to 6 times x minus 2. That is the equation of the line in point-slope form. If you're asked to get it in slope-intercept form, you simply solve for y, which is going to involve 2 steps. The first step would be distributing the 6, specifically in this case, the 6 into x and negative 2. So now you have y plus 5 is equal to 6x minus 12. And then the last step would be subtracting the 5 to get y by itself. So you end up with y equals 6x minus 17. So that would be slope-intercept form. You can get that from point-slope form. Here is slope-intercept form. The same m in point-slope form is the same m in slope-intercept form. That number won't change, and that will represent the slope in both cases. In slope-intercept form, the b value, the constant outside, separate from the number with the coefficient on x, that is your y-intercept. That is where the graph will cross the y-axis. All right, so graphing using slope-intercept form. You first plot the point containing the y-intercept on the y-axis. So you just plot that point. Whatever that b value is, it's 0, b as your ordered pair. You can obtain a second point by using slope. You write m as a fraction, use rise over run at the point of the y-intercept, and then you plot the next point. And then you just use a straight edge, draw a line between the 2 points. You're going to draw arrowheads at the ends of the line to show that the line continues indefinitely in both directions. So we'll do that here. You start with the y-intercept. Whatever the y-intercept is where you start. So since the y-intercept is 1, I'm starting at the ordered pair 0, 1. If that number was if that part of the equation was minus 4, then I would have started down at negative 4. Okay. Again, I'm given the slope. I don't need to do anything other than apply the slope. It's rise over run. 3/5 means up 3, right 5. So as I go up 1, 2, 3, right 1, 2, 3, 4, 5. Okay. And then I would apply a straight edge. I don't know if I can do that in. Hold on, let's see. No, I did not need to do that either. All right, whatever. Use a straight edge on your paper. That's pretty horrible. That's okay. All right. But anyway, you draw your line through the points there. Next time I'll use something that has a tool where I can actually draw a straight line on the computer. Okay. Now I was just going to go through all the steps I just did. Plot the y-intercepts. We already have the y-intercept. Rise of 3, run of 5. Again, we just talked about that. Plot a second point. We did that. Then you're going to draw a line through it. Okay. Let's talk about horizontal lines now. So we're just, again, running through the list of objectives we had. A horizontal line is given by the equation y equals b. B is a number, specifically the y-intercept of the line. And the slope is 0 for that horizontal line. For a vertical line, it's going to be x equals a number. In this case, that number will also be the x-intercept. The slope is undefined because it is vertical. Graph y equals 3 on there. So y equals 3 is a horizontal line with a y-intercept of 3. Knowing that, that's enough, because the first thing I would do is just plot my y-intercept of 3 and then draw a horizontal line through it. That's all you have to do. It was asking for a, plot or a graph x equals 4. That would be a vertical line with an x-intercept of 4. So I would just plot the x-intercept first and then draw the vertical line through it. General form. Again, this is what we called in algebra. If you had me for algebra, and quite honestly, I'm sure anyone at RA for algebra, we called it standard form. That's all they're called. It's the same thing. General form is standard form. It's ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b are not, both 0. So find the slope and y-intercept of the line whose equation is 3x plus 6y minus 12 equals 0. If I'm asked a question where I'm just trying to find the y-intercept and the slope, I'm going to put it in slope-intercept form. So the first thing I would do, I'll take the equation. Slope-intercept form, remember, is getting y by itself. So the first thing I would do is subtract the 3x to the other side. And then if I have 6y and I want y, I'm going to divide 6 from everything. And I end up with y equals negative 1/2 x plus 2. The slope is the negative 1/2. The y-intercept is 2. That's it. So again, if you need to get slope and y-intercept out of something that's in general form, then you put in slope-intercept form. That'll give you the information you need. Using intercepts. So if you're given something in general form and you need to graph, you could just convert it to slope-intercept form like we just did, and then graph it like we talked about earlier in terms of just plot the y-intercept and then apply the slope. So that is possible. Another way to do that, potentially faster way to do that, would be to find the intercepts. Intercepts are easy to get when it's in general form. So what you can do to find the x-intercept is you let y equal 0 and you solve for x. Then that ordered pair with 0 for y and whatever number you get for x is the x-intercept. Same exact thing for y. You let x equal 0 and then you solve for y. Now you've got 2 points and you can draw your line through it. So now we're going to practice that. Find the x-intercept by letting 0 equal y. So we're going to substitute 0 in for y, which essentially means it goes away. So now you've got 3x minus 6 equals 0. You add 6, divide by 3, and you get x equals 2. So the x-intercept is 2. We're now going to do the exact same thing for the y-intercept. We're going to let x equal 0. Again, that essentially means the x is now gone. So now you've got negative 2y minus 6 equals 0. You're going to add the 6. You're going to divide by the negative 2, and you get y is equal to negative 3. So now you've got a y-intercept of negative 3. Now we're going to plot both those points. The x-intercept of 2, the y-intercept of negative 3, and we can draw our line through it. Okay, that's it. So again, you could have done slope-intercept form with that. That would have been fine. I think it's probably faster to find the intercepts when you're already in general form. But again, that's just a preference. I'm not really necessarily going to make you do it one way or the other. Although Math Excel might. Sorry. It might like ask you along the way on a multi-step question, like what are the intercepts, blah, blah, blah. On a paper test, if we were in school, I wouldn't care which way you do it, but nonetheless, here we are. Okay. A summary of the various forms of equations of lines. Okay, so we just kind of went through multiple chapters of Algebra 1 in about, 15 minutes or so. This is all stuff that, again, review, you should know moving forward. We will be using this stuff as the year goes on, as the chapter goes on. So point slope form you should know, slope intercept form you should know. Horizontal lines you should know are y equals a number, and the slope would be 0. Vertical lines you should know that are x equals a number, and they are no slope. And general form is ax plus by plus c equals 0. I should point out, I've been saying it's the same, general form is the exact same as standard form. Standard form actually has the c value on the other side of the equal sign. A minor difference, but there you go. That is why it's called a general form instead of standard form, I suppose. Okay. All right, in application, we're going to use 2 data points to obtain a linear function that models average global temperature for an atmospheric carbon dioxide concentration of X parts per million, round M to 3 decimal places and B to 1 decimal place. Sounds complicated, but we're really just going to use some of the skills that we just talked about. The context doesn't honestly really even matter. We're given 2 data points, which means 2 ordered pairs. So the first thing we're going to do to create a model is we need to find the slope between those 2 points. So we're going to use the slope formula where we have x1 and y1 and x2 and y2. So 57.64 is substituted in for y2, 57.04 is substituted in for y1, 354 substituted in for x2, 317 substituted in for x1. You end up with 0.60 over 37. It said round m to 3 decimal places. So notice how we're not using an equal sign anymore. We're using that symbol. That is an admission that we are rounding, which again, if the context of the question allows that, then that's fine. So 0.016 is our slope. It's asking for, again, the model. So we're going to use point slope form to get into slope intercept form. We now have a slope. We have 2 points to pick from. So again, we're going to use point slope form. It doesn't matter. I know I labeled the first point as x1, y1, and that is the point we're going to use here. You could have used the x2, y2, and it would make no difference. In the end, you're going to end up with the same value for b, assuming no calculation errors. But again, we substituted that slope that we calculated on the last slide in for m, and the ordered pair that was previously given to us in for x1 and y1. We're going to first distribute the 16 thousandths into x and 354. You end up with that, and we're going to add 57.64 to the other side, and you end up with 51.976. Remember the question, and this is something Math Excel is going to catch you on. If it tells you to round to 1 decimal place, you need to round to 1 decimal place. So even though we were able to calculate it to 51.976, it asks you to round it to 1 decimal place. So the tenths column, it looks weird that we rounded it up to 52, but since there's a 7 behind the 9, that 9 turns into a 10, which makes that number 0. The extra 1 goes up to the ones column. So that's why it does end up being 52.0. Again, it's a fine point, but it's a point that Math Excel, if it's asking you to enter the number, if you type in 51.976, it will mark it wrong. Okay, so just keep that in mind. Pay attention to detail in terms of where to round, that kind of thing. All right, so then your answer to that word problem is a sentence such that the function that we created models the average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million. So again, I don't really need to understand the context of the question to create that model because I had enough information to just use the skills that we talked about earlier. Now we're going to use the function we created to project the average global temperature at a concentration of 600 parts per million. So you're going to substitute the 600 in for x, find f of 600, and you end up with 61.6. So the temperature at a concentration of 600 parts per million would be 61.6 degrees Fahrenheit. Let me know if you have other questions. At this point, you should have completed the 1.3 lesson quiz. So now you can get started on the 1.4 practice. Remember, send me questions on Ask Your Instructor. Check out the View an Example if you're stuck. You got resources, make sure you're using them. And again, don't hesitate to ask me questions. Shoot me an email. Best way to do it, again, is through the Ask Your Instructor, because then I can see exactly what you typed in. and you're welcome to just shoot me an email regular way too. All right. That's it. I will talk to you soon.